I will present VizCommender. This is joint work together with Robert Kincaid and Tamara Munzner, a collaboration between UBC and Tableau. Organizations and communities accumulate masses of visual data representations over time, and large-scale visualization repositories emerge, which leads to major challenges. Users have difficulty in discovering relevant content, and users often start from scratch instead of reusing existing content. Recommendation systems are increasingly used to assist users by surfacing relevant content. The Viz community typically uses the term recommendation in the context of recommending new visual encodings for a given dataset or a combination of data types. Examples are Tableau Show Me, Voyager, Draco, or Data to Viz. Recently, there was a lot of progress in this area, but automatically generated results are still relatively simplistic. Our goal is not to recommend visual encodings. Instead, we follow the more traditional terminology of the recommender systems literature, where recommendations are proposed for pre-existing items of content. We want to surface existing visualization workbooks that can be very complex, that have been created by users, and are stored in visualization repositories, such as Tableau Server. We can differentiate between two major recommendation paradigms: content-based filtering and collaborative filtering. Content-based filtering is the focus of our work. We want to find relevant items based on the actual content. These recommendations are usually less diverse, but more accurate. This approach allows also the identification of near-duplicate items, which are highly relevant in some cases, but need to be excluded in other cases. And then there is collaborative filtering, which doesn't look at the content itself or features of an item. Instead, it analyzes the interactions between users and items and derives recommendations from usage patterns. It's a popular approach because it requires no domain knowledge, allows fast computation, and leads to serendipitous recommendations. But a major disadvantage is the cold start problem for new items or users, besides being disconnected from the content. The advantages of both collaborative filtering and content-based filtering can be combined into a hybrid system. But that's future work and not the immediate goal of this project. Our process is driven by two key questions: which content features are most informative for comparisons, and what techniques can be used for comparing and ranking Viz specifications. As a result, we propose a text-based similarity measure for content-based recommendations to facilitate information seeking in visualization repositories. We worked closely with the recommender systems group at Tableau and interviewed machine learning engineers, a UX designer, and a product manager frequently. This collaboration allowed us to get insights into typical use cases and pain points related to working with large Viz repositories. In parallel, we extracted and analyzed features from Viz specifications and developed different generations of prototypes. To better understand the appropriateness of various content-based models, we conducted a crowdsourced user study where we compared human judgments with model predictions. I will explain it in a few minutes in detail, but these results of the study informed our proof of concept recommendation model, and we demonstrate its utility in our VizCommender prototype. But let's take a step back and look at the underlying data. We focus on Tableau workbooks that often contain multiple sheets and dashboards, roughly comparable to a spreadsheet. All components are described in the XML specification. We extract text content such as titles, captions, and access labels. And we also use the data source column names as additional text data, such as city, customer name, and sales, that are also part of the XML Viz specification. Originally, we considered using a combination of extracted text features and visual encoding features. We implemented it in a first prototype where we could define weights for the underlying topic versus the visual style. But visual similarity is tricky. Some workbooks are perceived similar, although they use different data and about completely different topics, as you can see here. In contrast, identical information may be visualized fundamentally different. For example, CO2 emissions in different regions as a bar chart or pie chart. we ultimately decided to leave out visual encodings. If the task is design inspiration or learning, the visual style is absolutely necessary. But we identified information seeking as the core task when browsing Viz repositories in enterprise settings, where the goal is to find informative workbooks around the user-specific analytical questions. So we choose to focus on the subject matter of a workbook and not the visual style, such as marks, colors, or layout properties. We argue that the visual style can add noise to the model when the task is purely information seeking. We identified multiple challenges related to extracted text data from Viz specifications. Most important, text in Viz workbooks is very different to normal text documents with sentence structures such as news articles. Often we have only single words or short phrases, so we try to use as much content as possible. A workbook often contains multiple dashboards or sheets, but we decided to only recommend whole workbooks and create a single bag of words. So we consider a workbook as the object of interest. We found many incomplete workbooks, so we use basic filtering techniques to exclude some of those. More work is necessary to better understand what low quality actually means and to implement appropriate filter options. We also found many duplicates or near identical workbooks. A content-based model should be able to identify those. Workbooks have a domain-specific nature and often use company internal vocabulary, which influences the choice of NLP models and the use of pre-trained models. So we start with a bag of words from a workbook, but how do we transform it into a vector? And how do we make comparisons in order to create meaningful Viz recommendations? To answer these questions, we conducted a review of models and selected a subset of 4 natural language processing models and distance measures: TF-IDF as a baseline, LSI, LDA, and word embeddings, specifically doc2vec and GLOV. In addition to an informal analysis of NLP models, we conducted a crowdsourced study to collect human similarity judgments and compared it with the algorithmic notion of similarity. Of course, many other approaches have been proposed to evaluate recommendation algorithms, such as A/B testing. But our goal was to analyze just the similarity measure as a first step, a comparative model analysis independent of the user interface. So how did we collect these similarity judgments? We sampled triplets of Viz specifications with 1 reference Viz and 2 alternatives each. And we asked 75 participants to pick the alternative that is most similar to the reference. Then we ran the same task with different NLP models and we compared the agreement. The study interface showed the extracted text and not the visual encoding. Participants were asked to select the most similar alternative based on the overall topic. Each participant rated 47 of these triplets, and we manually verified that the text is understandable and doesn't use extensive domain-specific terms. After the study, we computed agreement scores. Most relevant is the agreement between the participants and the models. On a scale from 0 to 1, the agreement is very high for all models. We observe a very good alignment between human judgments and off-the-shelf model predictions. All models achieved high agreement scores. LDA performed slightly better in our experiment. This is only a subset of popular NLP models, but our results show that more complex models don't necessarily lead to major benefits compared to simpler models. We don't have long English text documents that are rich in information, but our study demonstrates that meaningful pairwise comparisons are possible, which are the foundation for content-based recommendations, despite very limited text, no grammar, no real sentence structure. So we chose to implement an LDA-based model in VizCommender. We can select an example workbook and open its detailed view. This view shows an interactive version of the workbook. At the bottom of the screen is the recommendation panel, divided into different similarity facets. Our requirement analysis revealed that a single category of recommendations is not sufficient to capture all the tasks that should be facilitated. Therefore, we divided recommendations into 3 different facets. The goal of the related workbook facet is to show semantically related workbooks but not near duplicates. For the similar data source facet, we train a separate model with only data source column names. Very often we see multiple versions of workbooks, for example at 2019 and 2020 report, or as you can see here, different crime dashboards. We bundle them in the similar versions facet. In this project, we are focused on Tableau workbook specifications. But most visualization systems such as Power BI, Qlik, or Looker have similar textual features for describing visualizations. The feature extraction depends on the specification format, but the basic process we outline in our paper and the findings of the user study should be applicable to any repository of machine-readable Viz specifications. Please have a look at our paper for a detailed discussion of challenges related to content-based Viz recommendations. We contribute the design and implementation of a proof-of-concept recommendation pipeline consisting of feature extraction, pairwise comparisons, and the user interface. We analyzed different NLP techniques and conducted a user study to assess the alignment between model predictions and human judgments of similarity. And with that, I'm happy to take questions.